All right, so 4-5 in geometry is conditions for congruent triangles. Before we get started, I want to point out, in your homework, if it tells you to do paragraph proofs, you can make 2-column. Okay, you don't have to do a paragraph proof. If you want to do the paragraph proof, that's also fine. But whichever way you want to do it is totally okay with me. All right, so we've got some conditions for congruent triangles today. Is what we've got. So next up is the side-side-side congruence theorem, or the SSS congruence, like a snake. Right? So what do you think the side-side-side is going to say?
So
if you, yeah, side-side-side.
all the sides are congruent, then the angles are too, and makes the triangles congruent. There you go.
Okay, if all the sides are congruent
Uh-huh.
in two corresponding triangles, then the triangles are congruent. That's exactly what it says. Right? If each side of one triangle is congruent to the corresponding side of a second triangle, or to the corresponding sides, plural, then the two triangles are congruent. Ta-da! All right, so just as a review, we have the conditions for triangle congruence. So we've got side, 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 where all three sides are congruent, and so we can say the triangles are congruent. We have side, angle, side. Remember, it has to be the included angle. Congruence. Angle, side, angle. Here it's the included side, between the, because that's between the angles by included. Angle, angle, side. Okay, so this side does not have to be included. And then we have these other versions that do not work for congruence. We cannot have side, side, angle. Okay, that will not prove congruence because this angle is congruent to this angle, and that shows the side is congruent, and this side is congruent. But do those triangles look the same? No, they're totally different. And then this one is angle, angle, angle. Okay, so all these angles are the same, but this triangle is clearly larger than this triangle over here. Okay, so we can't have AAA, which is angle, angle, angle congruence. It's true. We cannot have congruence. It's true. Hopefully no one else ever watches these videos except for our students. I mean, they are public, but I'm like, hopefully no one else watches them. They'll be like, what is wrong with that class? All right. All right. So let's get into a theorem, or a proof, actually. Sorry. All right. So it started with, our proof started with just this one. Okay. That's what we've got first, is given this shape. I have just split it up, kind of, into all the other triangles that we're going to use. All right, so we're given that segment ED is congruent to BC. Okay, so I'm going to mark that. ED is congruent to BC. Can you see this yellow okay?
No.
Or puke color? No? Yeah. Yes? Okay. And BD, pardon me, is congruent to EC. So BD is congruent to EC. All right. So I went ahead and marked those from the given, and that was my step 1. Now, we want to prove that AE, right, this section right here, is congruent to AB. That's what we want to prove. So it's like a weird part of some triangles. Or we might say we want to prove that AB is congruent to AE. So those sides of the triangles. That's what we're wanting to prove. All right, so how do we, what connections, what relationships do we see that we could maybe list next? I mean, if I'm looking at this triangle, right, we have two sides congruent already.
DC and CD.
Oh, DC, he's saying DC and CD, those are the same line. So yeah, we can list those as congruent. Okay, so we want to say DC is congruent to segment CD. And what is that?
Reflexive.
The reflexive property of congruence. All right, so let me, I'm going to erase those and actually put my congruent marks on there. So this side is congruent to this side. So related to that, now that I have 3 sides congruent, Lucas, what statement can I make? Yep, right? These 2 sides are congruent? Okay, so tell me, name the triangles for me. Okay, so if you start D, C to E, you went, like, if I'm looking at this, so it's the 3 side to the 2 side. No, the 3 side. CDB. Good. So triangle CDB. Okay. And what is the reason for that? There's no angle. Okay, the side, side, side congruence. All right, very nice. So those kind of all went together. So we have just proven 2 of these triangles congruent. It does help us. Sure it does. Okay, so we've got those 2 triangles congruent. Well, yeah. So do we have any parts of the other triangle? EC. Ooh, if we go back, we know that EC here, EC was said, we said EC was congruent to BD. So that goes here. BD and EC were congruent, right? EC and BD. So those were congruent, and we just didn't mark them earlier. And then we have ED. We don't have an ED here. And DC. We don't have a DC here. Or DC, okay, but we still have those.
Well, can't you do now CPCTC?
Okay, what would you do with CPCTC? So the other thing.
Mark all the angles.
Mark all the angles?
Yeah.
Okay. Is there anyone in particular that would be, you mean up here?
Yeah.
Okay. So since this has 1 mark, I'm going to go ahead and put the 1 mark across from it. The opposite angle, just so we're practicing. You don't have to do it that way, but just so we're practicing opposite angles. Okay. The only thing is that's going to get really hairy when we go to list them. But it is true. Is there anyone that's in, like anything that's helpful there to angle? You thought there was? I'm not saying you're wrong. Okay. Yeah, we can. It's just figuring out what we can do. Maybe if we mark it on the bigger, like what we've got. So again, it's kind of nice that I can mark it and then erase it. But we've got E. Okay, so this triangle is congruent. I'm going to use a different color to this triangle. So of our big angle, we have 1 side. Well, but we're not doing our big angle, right? Because we want to know AEB. So then, maybe that's not helpful.
Angle E.
So angle E might be helpful. Okay. So then let's look back. So we're looking at, then there's this triangle inside here. That's where AEC came from. It's kind of on the wrong side. And then the other one is here, DBA. So maybe it would help if I look at those.
So angle E and angle B.
Angle E and angle B might be helpful?
Yeah.
Okay, so we're saying E here. Is E congruent to B?
Yeah.
right? And we can also look at the way we named them. DCE and CDB, they're in the same place, so they should be congruent angles. Okay, so 4 is angle E is congruent to angle B, and Y, we said that was CPCTC. We just had to check and make sure they were corresponding parts. So yeah, very good. Anything else that's going to be helpful there? Maybe, okay, hold on, we can't name them angle E and angle B because up here it's more than just E and B.
And they don't share a line together.
So it's angle, well, it's this E. So hold on.
Wait, so it can't be angle E is congruent to angle B?
Well, no, because E has multiple angles, so it needs to be angle DEC, right? Is congruent to angle if we're calling it DEC, then it's congruent to angle CBD. Is there, but that is helpful. So, but it's one of those where you have to like keep going back and forth. All right, are there any other angles that are helpful?
The opposite of those angles.
Let's go ahead, like this angle C here.
No. But the other angle of E and the other angle of B. The adjacent angles.
But we can't say anything about them because we don't know anything about them yet. They're not adjacent. Adjacent angle sum theorem. Yes. So you're saying for the next one. Okay. Okay. All right. So 5, you're saying, what are you saying then? So you said the adjacent angle sum theorem.
Yeah, angle AEC.
Okay, hold on. Somebody give me the adjacent angle sum theorem. What does that say? Okay, can you tell me what number that is so I can give it to Lauren to reference? 4.41. Okay. And then read it for me. Oh, wait, hold on. That's not adjacent angle. 4.41 is angle side congruence. Are we looking at the same thing?
Oh, you're on the wrong page, that's why.
Oh. I was like, that's not it.
Here, it's 2.7.2.
Okay.
You want to read it?
Here you go. No, he's got it.
Oh,
If each of the two adjacent angles is congruent to another angle in a second pair, the adjacent angles, then the larger angles are congruent.
But that one says if, hold on. If each of two adjacent angles is congruent to another angle in a second pair of adjacent angles. Each of two. Do we have that yet? Each.
I thought it had something to do with adjacent. Maybe it's not the sum one. Maybe it's the other one.
Adjacent angle portion, is that what you're thinking?
Yeah.
Okay, so let's look at that. So that's 2.7.3. If two angles, one in each of two pairs, okay, one in each of two pairs of adjacent angles are congruent, and the larger angles formed are also congruent, then the other two angles are congruent. Okay, so how do you know? What do you mean you don't know? So we need to change this. It's the adjacent angle portion theorem. Let's see, is it? I want the eraser. Angle portion. So how can we use that? So it says if two angles, one in each of two pairs of adjacent angles. So this is the adjacent angle you're saying right here, right?
Yep.
Okay. Let me erase this other little mark up here, what I thought you were saying earlier. Okay. And so if two angles, one in each pair of adjacent angles, so there's one in this pair and there's one in this pair, are congruent, and the larger angles formed are congruent. Do you know that these are the larger angles are congruent?
Yeah.
Why do you know that they're congruent? Because they're supplementary. Okay. So then the other two angles are congruent. Awesome. So what angles can we say are congruent here?
Angle AEC.
Angle A, okay, so I marked this one. Angle AEC is congruent.
To angle ABD.
AEC. I know, I was just checking. AEC to ABD. Okay. To angle ABD. Okay. So I did mine differently. But somewhere before we did this, we should have listed that the lines were supplementary, like linear pair theorem, right? So we should have, because we have to state everything, so we should have like in here. Okay, so let's have like a 4b. That angle, right? I'm going to put this in here. We're going to put step 4b in there. What about the linear, was it linear pair theorem? Yeah, angles that form a linear pair are supplementary. So what angles are, so angle AEC and angle, right, AEC and angle DEC are supplementary. Are you guys with me? We should have, we need to state that before we jump into this one. And then, so we have to do the same thing for angle ABD and angle, let's see, angle ABD and angle DBC are supplementary. So we get to insert in there because we should have said that they were supplementary so that we know then that we could jump to the adjacent angle portion theorem. Because then if they're supplementary, yeah, then the larger angles are congruent. And I'm trying to, what do you think? Do you think we should even do that? Like state that the larger angles are congruent, like angle AED is congruent to angle ABC? I mean, it's one I could see going either way, but we do need that like step 4b in there, like inserted in. Okay, so what from there? We need to find a side. Yeah. We do need to find a side, maybe. Okay, so I'm looking because mine is different. Hey, they both have an angle A. Yeah. Right? Like, well, let's see. Right? Because it's ADB, right? It's this ADB and AEC, so it's the same angle A. there. So I'm going to say step 6 is angle A is congruent to angle A. That's the reflexive property of congruence. And then we said angle B, right? Well, I'm just marking up here.
Yeah. Yeah, and then now you know it.
Angle B, yeah, is congruent to angle E up here. And so now we can say that the angles are congruent? Okay. So 7, triangle ABD is congruent to triangle AEC. And that was because of angle, angle, side.
Now
8 is CPCTC. So AE, segment AE is congruent to segment AB. Because corresponding parts of congruent triangles are congruent. And again, this is a different version than what the book had. Like I copied down what the book had, and it's a different version. But I'm good with it.
I'm guessing the other one had a lot of steps.
It did not. It had exactly 8 steps as well.
Oh, wow.
It was just here in step 4.
We had more steps.
In,
4B.
oh, that's true. Okay, we had 4B, technically. Okay, so we had 1 extra step. But it took a turn at 5 when you did your angle adjacent angle portion theorem there. With these these angles instead of a different set, that's what was different than the textbook. But again, it's all right. So sometimes there's freedom in being able to do the whole thing yourself, and sometimes it's nice to have the helps like, oh, use this theorem, what can you say? So with that being said, the next ones on the back, we have some helps too. So let's look at those. This is actually these are some examples from the book. They're not like that were homework, but I want us to practice through some of them. So Caden, you get to say nothing on these. Okay. This one here on 14. I want to hear from Justice and Lucas. All right, so number 14, we're given PQ is congruent to QR. So go ahead and mark that. Like that's one of the things. PQ is congruent to QR. And QS is perpendicular to PR. Okay, so those are perpendicular. All right, so we got number 1, our given. And then step 2 is the isosceles triangle theorem. How is that going to help us? The isosceles triangle theorem. Okay, Lucas, I'm sorry. Can you give me the number again? 4.4.2. Okay, so flip there, Lauren. Okay, go ahead.
If 2 sides of a triangle are congruent, the angles opposite of those sides are congruent.
Okay, so what statement can we make with that? So again, if 2 sides of a triangle are congruent, which we have these 2 sides, they're congruent, then their opposite angles are congruent. So what can you say? What angle is opposite of PQ? Right? Angle P touches, angle Q touches, so what's opposite? Lucas? R. Okay, so angle R is opposite of PQ, right? Because when we want opposite angles, opposite is the one angle that doesn't touch. It doesn't always look opposite maybe, right? But it's the angle, this side, the only angle that it doesn't touch is this one over here, because this one is part of, right? They touch this side. All right, so what angle is opposite of QR? P. All right, so we can say angle P is what? Yes! Awesome! Very nice. All right, so our next one, we're going to use the definition of perpendicular. What is the definition of perpendicular? Kaden, you can look up the definition for us of perpendicular in the back. I'll let you do that. If it's a definition, you probably don't have it. You'll probably have to look in your book. Right, those are glossaries and...
Well, I think I know it.
Okay, what is the definition of?
So perpendicular, like, comes into it perfectly, so the angles are cut evenly.
So the angles are cut evenly. Okay. Okay, Justice, that's you're not going to find your perpendicular. You're not going to find a definition in that paper. Okay. Okay, so the definition of perpendicular is segments, rays, or lines that intersect to form what kind of angles?
Congruent.
Not congruent. Perpendicular is more important than that.
Adjacent.
Not adjacent. We wouldn't. They are adjacent, but that's not helpful. Perpendicular lines. What kind of angles do they make? 90, which are called what? Right angles. Yes, they are right. Okay, so we could have. I almost marked that at the beginning because it just comes in, like it's just one of those things I think of naturally. They make right angles, so we can say angle QSR and angle QSP are right angles. Perfect. Ooh, so step 4, I gave you step 4. So angle QSP is congruent to angle QSR. Why? What'd you say? Oh, I don't know whose login that is. I keep trying to get rid of it. I don't know how. What'd you say, Lucas? Yeah, because all right angles are congruent. Because we use the word right angles up here. So all right angles are congruent. So absolutely, anytime it's a right angle, we know that it's 90, but we know that they're congruent. Okay, so now we have an angle congruent to an angle. Oh, sorry. Yeah, another angle congruent to another angle, and a side congruent to a side. Is there an angle, angle, side, or side, angle, angle, or something like that? Theorem? Because it's not angle, side, angle, right? The side's not included. So do we have a theorem that we can use 2 angles and a side? Or it might say a side and 2 angles? It would be angle, angle, side, yes. So the angle, angle, side congruence says that triangle PQS is congruent to triangle RQS. Woohoo! So good. Dun, 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 dun. All right. Lucas, you got this? Okay, perfect. All right, so 16 is a flowchart. We're just going to practice with this flowchart one to see how that goes. Oh, let me move it down. Okay. So we're given AB is parallel to BC. All right, that's already marked. BC is parallel to AD. And we want to prove that triangle ABD is congruent to triangle CBD. So ABD, right, is congruent to CDB. Okay, we want to prove that those are congruent. So I'm actually going to put a C here and an A here. It helps me with my naming, and a B and a D there. Yeah, because I like to redraw them. Okay, so BC is parallel to AD. What was that? Given. Okay, so in the flowchart, because again, we're practicing with this flowchart, we're going to write given underneath there. What was our other given? Yep, BC. Oh, my bad. Okay. AB is parallel to DC. Okay. Awesome. All right. So given this and the alternate interior angles congruence, what can we say? Wait, what do alternate interior angles, what do they relate to? Transversals and parallel lines, right? We have to have parallel lines. So if BC, so let's see, I'm going to erase these angles here. And, okay, so BC is parallel to AD. So BC, so we're looking at this set of parallel lines is our focus, and this transversal. Mm-hmm. Angle 4 is what? Yeah, angle 4 is congruent to angle 1. Those are alternate interior angles. Sure. Then we could do, so with the next one, right? Angle, we're looking at AB being parallel. Let's see. AB is here, right? AB is parallel here, so those are our parallel lines. So now we can say angle 2 is congruent to angle 3. Is that what you're saying?
I did it the other way and just called them alternate exterior angles.
Okay. But they wouldn't be, they would still be alternate interior.
Well, I thought 4 and 1 were exterior, but
Okay, let's see. Let's go back. No, you're good. 4 and 1 were exterior. Okay, so they're interior here. Well, let me go back to green too. So they're interior to the parallel lines, but 2 and 3 are also, you can come in. Oh, okay, so now. Gotta love it. Okay, so we can't say 2 and 3 here because they, it would have to be this whole angle here would be equivalent to this angle, right? But 2 and 3 are like cut by this other set of parallel lines. So Justice, this will be online for you to finish your notes. Oh, okay, you don't want to watch the video? You just want the... Okay, I say, sounds good. That's very nice. Okay, so the problem with saying 2 and 3 are also congruent here is because it would have to be this whole angle, not the part that's intersected. Does that make sense? So let's, so we have to look at the other set of parallel lines for that one. So that's where AB, AB is parallel to CD, and this is our transversal. Well, now we can say angle 2 because it's between the parallel line and the reversal, or the transversal, and angle 3 are congruent. And so what would the reason for that be? What's the relationship between angle 2 and angle 3? Alternate interior angles again. So alternate interior angles are congruent. Yeah, right? You put again. It's true. So at this point, if we kind of look at this, we have angle, doggone. I keep trying to change color and everything changes. Angle 1 is congruent to angle 4, so I've got those marked. Angle 2 is congruent to angle 3. We can almost prove congruence. Like we're almost to this step. We have two angles, but we need an included side to do angle side angle. There is an included side?
Yeah.
What would it be?
Actually, we know all the sides. No, never mind. Okay. BD and BD.
So BD, is it BD and BD?
Yep. No, it's BD and DBD.
Okay, BD is congruent to segment DB. One way you can look is here, in this triangle it's BD, and this triangle is listed as DB. And why are they congruent? They're reflexive. Good, the reflexive property of congruence. So now that we know these are the same, we can say, make the statement, triangle ABD is congruent to triangle CDB because of, Lucas, because of, Lucas? Nope, angle will never work. Remember we talked about that one earlier. That's one that won't work. On the front of this sheet, if you flip it over, there's the four that work and 2 that don't. It's not angle side. You're right, because it's the same letters, but it's the included side. So it's angle. So because it's included, right, we have an angle, and then we have what? What is angle side angle? So yes, this is angle side angle congruence. Perfect. All right, and let's look at one more together. I think it's better to have lots of practice with the proofs together than just doing them on your own all the time, since it's been a struggle, right? All right, so this one is number 20. Again, they're all the even, so they weren't ones you were going to do. So given the figure, we want to prove that AD line, notice it says line though, not segment, that line AD is parallel to line BC. So it works. I like it. What does the figure give you? Because like that's all we're given. So we have to look at the figure and what does it give us? Right? These markings mean a lot. Okay, we could not angle A.
Yes.
No, because angle A is split, so we can't call it angle A.
Line AB.
Okay, so you just want to go to the line instead. I see how it is. Okay, so segment AB is congruent to, okay, if you go from A to B, you need to go C to D. Okay, that's given. What else is given?
Angle BAC.
Okay, angle BAC
is congruent to angle AC or DCA.
Okay, so BAC is congruent to DCA. Perfect. Those are both given. Very good. Yeah, your turn, Lucas. I like it. You might have to write a little smaller than me. Cram it in there. How do you know that? We can't do that yet. But they do share a side. The triangles share a side. I don't know. They must be crawling. There's no bathroom. What side do they share? Because they're touching. So what side do they share? It's like the transversal. That's the reflexive property, yeah. So the reflexive property of congruence says that AC then is congruent to what? To CA. Good. Because it would be CA, right? Because we start at this angle. So if we rename it, we're starting at this angle. We need to come back and say CA. Good. All right. Very nice. So then step 3. So we've got side, angle, side, right? Because we've got angle, or we have side, angle, and side. So triangle. Do we just want to go with this naming since we've already done it, like BAC? Okay, so triangle BAC is congruent to triangle DCA, and it's because side, angle, side congruence. Oh, my wavy line doesn't look very wavy. Okay. So again, we're trying to prove that AD is parallel to BC. AD is parallel to B. Well, wouldn't we want to say that these angles, this angle is congruent to that angle with CPCTC? We good with that? So angle DAC is congruent to angle, let's see, BCA? DAC, is that right? DAC, B, right? So DAC is congruent to BCA. Yeah. Okay, because corresponding parts of congruent triangles are congruent. All right. Any idea why I chose that one? Okay, because we want to prove that AD is parallel to BC. And so if this is the transversal, what would be the relationship between these two blue angles here? Alternate interior angles. So it's like the converse. Because these are congruent, right? Shouldn't it be the converse of alternate interior angles, essentially? So, what is that? I don't have that. Is that a converse? Where is... I don't have my theorem sheet. Did I let somebody borrow it?
No.
What? I don't believe you. No, this is my glossary. Because I have printed off the glossary out of the back of the book. It's too hard to find. Okay, let me see. Because what I have written down is congruent alternate exterior angles. Oh, you can't see the blue. Sorry. Congruent alternate interior angles means the lines are that we have parallel lines. So it would be that AD, line AD, is parallel to line BC. But yeah, I think maybe Justice picked up my paper. Okay, so unfortunately that's the bell. Hopefully, again, it's helpful to walk through more proofs than not.